Hi guys, welcome to lesson of ordinary differential equations. So in this class, we are going to discuss non-exact equation case number 2. So previously we discussed about case 1 of non-exact equations to make them exact by using some transformations. So now we have case 2. If we have a non-exact equation, that is if dawa m over dawa y is not equals to dawa n over dawa x, then what we are going to do here is we are going to simply find dawa n over dawa x minus dawa m over dawa y divided by m, and we are going to check that whether this function is simply a function of y or not. If this is the function of y only, then we are going to say that the integrating factor will be simply exponential to the power f of y dy in the integral, right? So let's take some examples and then we will see that how to formulate these types of equations. So there's a simple question: y to the power 4 plus 2y times dx is, and then plus xy cube plus 2y4 minus 4x times dy is equals to 0, right? Now we are going to check whether the equation is exact or not. So dawa m over dawa y will be equals to 4y cube plus 2, and then dawa n over dawa x is equals to y cube minus 4, right? So we can see that these functions are not equal. Therefore, we can simply saw that this given equation is non-exact, right? So to make it exact, first of all we will look at case 1. If we can make a function of y only, but we can see that these both functions are functions of y, so we cannot make a function of x from these equations, right? So we can only get a function of y. Therefore we will use this approach, that is of case 2, dawa n over dawa x minus dawa m over dawa y divided by m, right? And we will check that whether this is a function of y or not. So dawa n over dawa x is y cube minus 4, then minus 4y cube minus 2, right? So it will be divided by m, that is y4 plus 2y. And here we have y cube minus 4y cube, which means that is negative 3y cube, and minus 4 minus 2 is minus 6, divided by y is common, so y cube plus 2 inside the bracket, and then this is equals to negative 3 is common, take it outside, y cube plus 2 divided by y times y cube plus 2. So y cube plus 2y cube plus 2 cancel out, and then we are left with negative 3 over y, which is a function of y only, right? So now it's pretty simple, and we can just find the integrating factor by using the exponential formula, that is e to the power f of y dy. So it will be e to the power negative 3 over y dy in the integral, right? So now by solving this integral, we will get simply 1 over y cube. So this is now our integrating factor, and we will multiply this integrating factor by the whole equation. And then after that, we will check that whether the equation is exact or not, and surely we will get an exact equation, right? And then we can simply solve that equation by using the procedure of solving exact equations. So this is dx plus xy cubed over y cubed minus plus 2y4 over y cube, and then we have minus 4x over y cube times dx dy, this is equals to 0, right? So here we will be left with y plus 2 over y squared dx plus x plus 2y minus 4x over y cube times dy is equals to 0, right? So now we can check dawa m over dawa y. This is equals to 1 minus 4 over y cube, and then dawa n over dawa x is also equals to 1 minus 4 over y cube, right? So these functions are now equal and the equation is hence exact. Just simply we can integrate by using the method that we already discussed in the section of exact equations, right? This will be x plus 2y minus 4x over y cubed times dy is equals to 0, right? So now here y is constant and x is equals to 0, function of x, every function of x, which means this is 0, this is 0, right? So wherever the x is involved, we will simply make it 0. And now this will be integrated with respect to x, uh, making y as constant. So it will be yx plus 2x over y squared, and then plus 2y here. So it means that it will be 2y squared over 2 is equals to c, constant of integration. And then we will simply left with xy plus 2x over y squared plus y squared is equals to c. All right. And in this way, we can just solve these equations that are non-exact and that can give us a function of y by taking the difference of the partials and then dividing by m, right? Let's take one more example. In fact, the last example for this session. Yes, we have a question that is x squared y squared plus y to the power x times dx minus e to the power x dy is equals to 0. Now the first step is again to check whether these are equal or not, the partials. So partial m with respect to y will be here 2x squared y minus e to the power x, and then partial with respect to x will be negative e to the power x, right? So these are not equal. So to make them exact, now we will use this formula, that is dou n over dou x minus dou m over dou y, that is divided by m. You can also check it for case 1 if it's a function of x only or not by using the formula for case 1, but here we are doing directly because we know that we will not get a function of x independently by that formula, right? So it's negative x minus 2x squared y plus e to the power x divided by m, which is y is common, x is squared y plus e to the power x, right? And this is by mistake written as negative e to the power x. This is in fact positive e to the power x, and then we will have negative e to the power x here, right? So it will be negative 2 e to the power x minus 2x squared y divided by y times x squared y plus e to the power x, which will be equals to negative 2s common, e to the power x plus x squared y divided by y times x squared y plus e to the power x. So these terms can be cancelled out, so we're left with negative 2 over y. So we can see that negative 2 over y is simply a function of y. Therefore, the integrating factor in this case will be e to the power function of y dy. So it will be e to the power negative 2 over y in the integral and dy, which we will get after solving 1 over y squared, right? So now this is the integrating factor, and we can simply multiply this integrating factor by the equation with the whole equation that is given. So we will get now x squared plus e to the power x over y times dx minus e to the power x over y squared times dy is equals to 0. Now check that whether the equation is exact or not. So dou m over dou y is equals to negative e to the power x over y squared, and dou n over dou x will be equals to negative e to the power x over y squared. So both the functions are now equal, the derivatives. So uh, the equation is exact and we can just solve it using the method of exact equation. That is x squared plus e to the power x over y times dx, where y is constant in this integral. And then here we have minus e to the power x over y squared, and the function of x is 0, right? So this whole will become 0, is equals to 0. So we'll integrate this function. We will get x cubed over 3 plus x e to the power x over y is equals to c. So that is the answer for the given equation. That was non-exact, but we make it exact by solving, by using the formula, that is dawa n over dawa x minus dawa m over dawa y, right? So let's check it again, if so that there may not be any mistake in the problem. So it's e to the power x over y, which on integration we get x e to the power x over y. Sorry, that is e to the power x only, because the integral of e to the power x is e to the power x, right? So this is the final answer for this problem. And you can take some more problems of these types, and in the next lesson we will discuss case number 3, and then after that we will discuss the case 4 for the non-exact equations. So that's all for the time being. Thanks for watching the lesson. Goodbye.